the same capabilities that give us like really creative and interesting like solutions to problems that like Move 37 could also produce like really undesirable creative solutions to problems that we wouldn't want AI to solve.
Victoria Krakovna. You are a research scientist at DeepMind working on AGI safety, and you're also the co-founder of the Future of Life Institute. You have recently been publishing multiple blog posts, including DeepMind Alignment Team opinions on AGI Rune, paradigms of AI alignment, and refining the sharp left turn. I remember we met about 4 years ago in Prague at some alignment conference, and it's an honor to be here today in the DeepMind office to record a podcast. Yeah, thanks for coming.
Thanks for hosting the conversation.
Yeah, no worries. So to start this, I think it would make sense to jump on this like very important blog post you published on the alignment team opinion on AGI Rune, because this was like post written by Eliezer Dudkowski, I think at the beginning of the year, and yeah, it was very insightful to have like the opinion of people from DeepMind on this blog post. So yeah, can you maybe like explain what the post was about? Not your post, but the one from Eliezer, and maybe like who Eliezer is.
Yeah, you can probably also explain who Eliezer is. I think.
But you're the guest here.
Yeah, sure. And Eliezer is a founder of the Machine Intelligence Research Institute, so he's been thinking about AI alignment for a long time, and he wrote this post summarizing various arguments for why he thinks that AGI is likely to cause catastrophic outcomes for humanity.
What's AGI for people who are not familiar? People from the ML community.
AGI stands for Artificial General Intelligence. It's it's a hypothetical kind of general AI system that would be able to do anything a human can do, or like perform like the vast majority of tasks that humans can perform, which is distinct from like the current AI systems that we have now, which are called narrow AI systems that perform like specific tasks or like that can like handle specific domains but cannot do like everything a human can do.
And so in this post, Eliezer goes into giving some examples or a list of ways in which this like kind of general intelligence could cause some existential threats. So did you say existential threats? I forgot, but yeah,
it's a catastrophic outcomes.
Yeah. What's a catastrophic outcome?
So like the idea is that if we have like a powerful like general AI system that can can do a lot of things humans could do, or that is superhuman at like in most domains, then like the system would be able to like gain control of the world basically, so that humans would no longer like be in control of the world. And then like if this system has like goals and preferences that are not aligned with what we want, then this could lead to really bad outcomes for us.
And I guess your post kind of shed light on this by having people from the DeepMind alignment team, so maybe like not all of them, but like some sample of the alignment researchers there, given their opinions. Why did you wrote this post? Like, what motivated you to write this post?
So I think when the AGI Rune post came out, like I personally found it to be like a useful kind of collection of arguments for like why AGI could lead to bad outcomes, or why like alignment is difficult. I think many of those arguments have like appeared in the past, but it was nice to kind of have it all articulated in one place. Something I was wondering about is like, how should we think about this in our team, and like how do people kind of talk about how much do people agree or disagree with these particular arguments, and also like how should this affect our overall strategy in terms of our like research priorities. So we were just having some discussions about about the post and about the arguments and kind of what they imply for our work. And then it occurred to me that like it's easier to keep track of this if I kind of collect people's views in a survey, and then you have a nice spreadsheet where you can see like how much like agreement or disagreement there is within the team, and like which kind of claims are the most controversial that maybe we want to like discuss more, or like figure out why we disagree and so on. So this started out as an exercise in terms of like an exercise in understanding like the distribution of views within the team, and like just discussing the arguments and kind of clarifying our thinking about AI risk, and then like once I had already collected this this information about people's opinions, then it seemed like this might also be of interest to the wider community and not just to us. So that's how it became a post.
Yeah, and I think it was very useful for a lot of people because instead of having someone like only one person writing a post with a bunch of arguments, we saw that like there was like I don't know maybe like 8 researchers that kind of often agreed with the claims, not all the time, but there's like some people in industry that also agreed with some of these claims, so it kind of gave more yeah more seriousness to the claims that were being made than just like one person writing a post. Yeah, did you learn anything from writing it? I guess like did you expect that most people would agree, or yeah, this is an oversimplification, but like were you surprised by some of the answers, or
Yeah, I think there were some surprising things in there. Like I think just like the level of disagreement in some of the arguments was a bit surprising. Like I think there were like some things that I like expected people to agree more on. I think overall, like maybe it wasn't like very surprising, but also just like kind of the specific reasons that people gave for like for agreeing or disagreeing were interesting.
and one thing you write is that it's not really about agreeing about the argument, so you can agree with the argument being true because he writes in a very clear way, and he tries to make something that is logically right. But maybe even if the statement is right, it doesn't imply that there is a high risk or a high threat. And so you can agree with the arguments without agreeing that the arguments are imply some huge risk at the end, right? So there's like various levels of agreeing with the claims.
Yeah, I think this happened relatively often. Because I think often like the arguments were made kind of based on a particular framing, and then like people would kind of disagree with the framing or disagree with some of the assumptions, and then like yeah, they might agree with the argument as stated, but then like if they disagree with the assumptions, then like they wouldn't agree with the kind of the implications for risk. So like I think there was one argument, for example, where like the idea is that you can't iterate on dangerous domains where you deploy AGI. So if you have like if you are like deploying a very general system in the real world for the first time, then you might not kind of get another try if you get it wrong because maybe the system will resist correction and so on.
You need to get it right on the very first try.
Right, and that's so that's something that like people might kind of tautologically agree with, that like if you define a dangerous domain as a domain where like you cannot iterate, then like this the statement kind of becomes sort of trivially true. But then like there are some things that were kind of implied by the argument that for example, like iterating on less dangerous domains will not teach us anything for iterating on dangerous domains, and that was maybe not like completely explicitly stated in the argument itself, but that's something that, like, for example, Paul Christiana was pointing out in his response, that like that you wouldn't agree with the implication that like we can't iterate at all because we could iterate in like maybe like somewhat similar settings where like we can still shut down the system and so on.
So we might see like some failure from developing somewhat general systems, but we will not be able to test alignment techniques or like over like 1,000 runs or something, and we will only have we will only be able to test things in the dangerous domains for the first time. Is that basically right?
Do you mean as the restatement of the argument?
Yeah. So well, I guess in the post it says something like you can only deploy it once or test it once in the dangerous domains, and the restatement that works is something like you won't be able to test it 1,000 times in so you won't be able to do like machine learning testing or benchmarking on the dangerous domains.
Yeah, sure. I think you can put it that way. But the kind of like counter argument that we would make is that like you can have like similar domains that are less dangerous that you can learn from, and that you can like find a lot of issues by testing there, and like ideally you would not want to deploy your system in dangerous domains at all. And
Right.
I think that that's another thing that's like there's this implication in this argument that you will have to deploy your system in dangerous domains because there's this whole idea that like in order to like save the world you have to perform like a pivotal act where like a pivotal act is like some kind of intervention where like you prevent anyone in the world from like launching an unaligned AGI system. And like I think Laser and like Miri in general believe that like you can only do that by like deploying your own AGI. And then like of course if you are like trying to deploy a system to uh, uh, to prevent anyone else from deploying an AGI, that's like that's actually a pretty dangerous thing to do. But that's one thing that like that people at least in our team disagreed with the most, that like the whole idea that you might want to do this, or not to mention that uh, that you would need to do this, because it just generally seems like very risky and bad, but a bad idea. And like I think like that framing kind of bakes in the assumption that like there's no other way to avoid unaligned AGI being deployed by by other actors like that. I think that like also kind of um, you know um, I think this assumption kind of relies on some of Miri's pessimism about like being able to coordinate to like slow down or like develop kind of safety standards and so on.
So you think there will be like more time to coordinate between different actors, and we won't be in the need of some like pivotal act where we need to like deploy an AGI in the wild to prevent other AGIs from being deployed?
Yeah, so I do like feel somewhat more optimistic about cooperation in general, especially like if like especially like within the West, like between like Western AI companies, like it seems like possible and definitely worth trying. Like global cooperation is more difficult, but that like may or may not be necessary. But also like I think both myself and others in the team would like object kind of to the whole framing of like a pivotal act, as opposed to just doing things that you would need that increase the chances that like an unaligned AGI system is not deployed. That includes cooperation, that includes like continuing to work on alignment research.
So they're doing like continuous progress and
continuous progress, that like as opposed to like focusing on this very specific scenario where like some small group of actors would take some kind of unilateral action to like to try to stop unaligned AGI from being deployed. And that just seems like that just generally seems like a very bad idea. And I think it would be very likely to like lead to more harm than good. And I think in practice, like you would never be like confident enough that your AGI is aligned to like feel confident that like using that AGI to like quote quote perform a pivotal act would not be very harmful. So in practice, I think you would just never do that.
Yeah, it's like too risky, and I guess the situation is not like dire enough, or there's like no situation where you would be justified to do this.
Right, but also like it's just it's just generally like a bad idea to like act unilaterally in that way, as opposed to like try to foster a kind of broader cooperation to like to make sure that deploying AGI goes well, because I mean this is something that's like in the in the interest of everybody.
So you mentioned unaligned AGI multiple times, and we'll go into definitions maybe later, very precise. But just quickly, what do people mean by unaligned AGI, or just aligning the AGI?
So what I mean by unaligned AI is like an AI system that like knowingly acts against human interests. So I don't mean like a system that like causes harm by accident. I think that's a different category, which of course can also be bad. I mean like a system that has like that has goals that are kind of in conflict with human goals or like human interests. So yeah, like I guess broadly speaking, we could say that like aligned systems are like systems that kind of do what we want them to do, and like respond to feedback from us about what we want them to do, and that, like this is sometimes called corrigibility.
I think there's also the definition where you specify that it's like it's trying to do the thing you're wanting to do. I think it's like intent alignment.
Right. Yeah. Yeah. So that's kind of what I'm pointing at, because like a system doesn't have to like perfectly understand what we want in order to be aligned. It has to just be like trying to do what we want, and then like similarly to how like if we're trying to help another person, we might not know exactly what they want, but we will like pay attention to kind of what they're telling us about what they want, and like update a model of like what their preferences are and so on. So that's a kind of how corrigibility works for humans, and we would kind of that's the kind of what we would want the AI system to do as well. So even if it's like if it starts out very ignorant about what humans want, as long as it's corrigible, it can like converge to like a good kind of working understanding of what we want in order to like be helpful rather than harmful.
So yeah, you mentioned the pivotal act as like one disagreement you have. Is there any other points you remember you disagree about, or you personally feel you disagree about the most?
I think like a general area of disagreement is like about how promising is interpretability work, because I get the sense that like Eliezer and maybe Miriam more broadly like are very pessimistic about like interpretability working at all, while like yeah, we think that there's like a decent chance of like making progress on interpretability, and like having some visibility into like how the model is like representing its like beliefs and goals internally. Of course, this is we still think it's like it's quite difficult, and like we need like more time and more kind of good researchers like working on it. We have we now have like a mechanistic interpretability group within the alignment team that started about a year ago. So yeah, that's one kind of general like research priority for us.
Is it doing work similar to what, for instance, like Anthropic is doing, or
Yeah, it's really related. Yeah, and kind of similar flavor to what Chrysola's group is doing.
awesome? So I think okay. I think it would make sense to go on more specific questions, because I think what was very useful in your post was that there was like the so you were kind of summarizing the argument from Witkowski, and you were also giving the comments that the specific researchers were giving for like why they agree or disagree for specific things. So yeah, a lot of people commented on the statement 4. So the world cannot just decide not to build AGI, and I guess everyone said it was unclear. Yeah, do you have any like ideas on what a world where we decide not to build AGI at all would look like, just like international agreement to not build AGI?
I think one thing I could imagine is if something goes wrong with AI kind of on a on a smaller scale than like a catastrophic outcome, but like that's something that still like makes a lot of people concerned, and like I guess some kind of warning shot, and or like I think like I think it is possible to like shift the view of the ML community, like how concerning this is. And of course like I think if there is like and I think governments would like you know have some kind of response to warning shots as well. So like I think the way I imagine this happening is that like AI systems gradually become more advanced, and they're kind of used for more different applications, and like at some point like enough things go wrong where like the system acts in some kind of unpredictable way and causes harm, maybe like damage to infrastructure or something like that.
Like a server would be like corrupted, or what kind of damage?
I guess like probably more than that, but like yeah, I don't know if I want to go to like very specific examples here, but yeah, I could imagine like if you have an AI system like in charge of the power grid, then like it could cause a blackout or something, or maybe like things that are more serious than that. I think like eventually we might see these kind of issues once like AI systems are like deployed more broadly. I think also like yeah, there might be like some kind of scenarios where like an AI system like uh, breaks out of containment or like accesses some kind of resources or like accessing the internet when it's not supposed to, and then like maybe like hacks into some servers or like steals money or whatever. Then like yeah, I mean there's lots of things you could imagine here, but like I think it's possible to like shift the broader opinion towards like these systems being potentially dangerous, and like I think like yeah, depending on like how well like AI governance work goes, I think like cooperation to at least like slow down research towards AGI is it does seem possible. I mean, yeah, I'm not a governance expert, so
Right.
I think there are like people who would have more informed takes on this than I do.
I think one disagreement was like, how much can we like buy time by doing this? And I guess like in my mind, imagine we're in a world where we're able to have an AI that is able to like turn off some power grid or hack into systems. We would have then like a bunch of people that might get access to it via open source. Maybe like a few months after the top labs have access to something like this. So yeah, I'm not sure like how much time we can buy.
Well, there would have to be like I think the publication norms would need to be more strict as well. I think like various like AI labs might have like might acquire like more stringent publication norms also just for like competitive reasons. But also like yeah, I think it's also from a safety perspective, like advances towards AGI like would not make sense to kind of publish immediately and like allow any like bad actors or careless actors to to use them through by making them open source. I think that's like yeah, I think yeah, that's one thing that like I would like like I think that's one shift I would want to see like in the kind of in the views of the ML community, is that like I think currently people still see like open source as like an unequivocal good. Like you should always like openly distribute your technology, but I think like people don't always think about like what are the implications of this, like in the limit of like the power of this technology, and that like if you actually have increasingly general AI systems that like could be like used in a lot of ways that lead to bad outcomes, then like it's pretty irresponsible to like open source advances like that. Even though of course there would be like a lot of benefits as well, but you just have to be like really kind of weigh the pros and cons and like be careful about that.
Yeah, I think this relates to a lot of people when they discuss info hazard. Like, so when you have some paper, let's say a paper about scaling that is very useful for scaling models, but can lead to faster timelines. So a date where we release AGI that is much sooner than we would need. So yes, so someone on Twitter, when I asked like what question would you like to ask Victoria Krakovna, asked me like what do you think would be like good like info hazard policies? Like always like have a committee deciding if a paper is dangerous or not, or or like have some kind of agreement of not releasing papers that speed up timelines too much. Like, yeah, do you have any ideas on how to do this? Or
Yeah, that's a good question. I think like having like any kind of review of this kind at AI labs would be useful. Just like even like some kind of light touch review where you flag whether like whether some paper might constitute like a sufficient like advance in capability that like might be worth like reconsider like whether to publish it or how to publish it. Just like having that thought process happen at all like already seems good. So like yeah, sometimes there's like you know there's some default way that like papers get reviewed internally, and like this I think ideally this would just like become one of the considerations. Uh, like you know uh, whether they should be careful about publishing the paper.
I think this will like highly depend on like if people are pro building AGI or against, or maybe like see more risk or less risk in building AGI. So in the comments about the claim about pivotal act, one person said that it was kind of dependent on whether there will be like a tiny group of researchers trying to build AGI, and the entire world will be against it or not. And I think like you only want to have a pivotal act if like the entire world is trying to build AGI. So you want to like do a pivotal act for like shifting the let's say the tendency, right? But if the concerns start piling up and everyone agrees that it's like a risk, you might not want to do this. Like yeah. So yeah, do you think we're gonna reach some kind of place where most people will see the risk, or maybe like until crunch time, until like when we get very close, most people will not see the risk?
I think like most people just haven't thought about it very much, and yeah, I'm not sure whether it's worthwhile for like regular people to think about this, because there's like there's just a lot, like there's a lot that like I think a person has to learn about, like what the alignment concerns are about, like why alignment is hard and so on. And yeah, I think like this doesn't seem necessarily that useful. I think like I would want like most machine learning researchers to see the risk, or like at least having like a good intuitive understanding for like why alignment is difficult, or why like this like that same way that like we fix problems for narrow systems might not work for general systems.
So yeah, you mentioned narrow systems and general systems. So one claim is that some problems only occur above like a certain intelligence threshold. I think it's like claim number 13. And I guess some people in the alignment team were saying that they expect like some problems to also arise in less intelligence systems, so like goal misgeneralization or reward tampering. So yeah, do you mostly agree with this? Like maybe define reward tampering and goal misgeneralization if you want.
Do you mean whether I agree with the general argument?
No, maybe more specifically, if you think like those kind of things, we would see them in less intelligent systems or not.
Yeah, I think like we're already seeing some examples of goal misgeneralization, although like these are like somewhat less concerning examples, but then they can still teach us how the phenomenon works. So goal misgeneralization is the idea that like you have a system that's like trained with a certain like objective function, but then like it only observes that objective function on on the training distribution, and then like there are different ways to like extrapolate that outside the training distribution. So like it might not learn the intended goal from the training data, but some other goal that coincides with the given objective on the training data.
What do I mean by goal here?
I mean, we still don't have like a very good definition of what goals are, but yeah, we mean goal in like a behavioral sense, where like the system learns to take actions that kind of bring the environment into like some particular like target states or like target configurations. So like one example of goal misgeneralization is this like this example that came up in the game Coin Run, where you have like you have this agent that's supposed to like it's trained to like go through the level and like avoid enemies and obstacles, and then like reach the end, and at the end there's a coin and it collects the coin. That's the reward. And so here like could say there are different possible goals. You could say like reaching the end is the goal or finding the coin is the goal, and then like it might learn to pursue either of these, like based on how it's trained. So like when they tested it outside the training distribution by like putting the coin somewhere else, they just kind of ignored the coin and kept going. So it seemed like it has clearly not learned that the goal is getting the coin.
Right.
And it's like it was behaving in a way where like it was still going to the end of the level. So it seemed like that was the goal of the system. Of course, we can't we can't look inside the system and like point at some components like, oh, this is representing the goal. So we don't know like how it's representing goals, but we can we can think about it like behavior of the system in new situations and whether it's like competently acting towards an undesired outcome.
You can see like if the system is predicting high reward when it sees the end of the level with like a wall at the end, or if it sees like high reward when it sees the, like you can see the activation of the neurons whenever it looks at the coin or whenever it looks at the end of the level and see whatever. Maybe it's kind of hard because
it's a bit difficult to do. But I think the idea with goal misgeneralization is that like you have like generalizing capabilities, but the goals of the system don't generalize like in a way that we would like them to. So like for example, when the coin run agent was deployed in this new environment, it could still avoid obstacles and enemies and like move through the level. So it was acting competently. It wasn't just kind of like flailing and doing random things. And it was competently acting towards an objective that was not what we intended. So it was like, kind of deliberately like going to the end of the level instead of like collecting the coin as we would want.
So yeah, it's different from just like something that doesn't generalize in computer vision where your thing just doesn't work at all. It's like it's competent, it's both good and doing the wrong thing. So it could be like dangerous for AIs that are deployed in the real world and like good but doing the wrong thing.
Yeah, that's the idea, that like you can have like particularly bad outcomes for the intended goal if the system is like competently doing something else rather than just acting randomly.
Another claim is that
so I think you were asking about whether some of these problems will occur before like the kind of superhuman intelligence threshold.
Right.
I think this might also depend on the problem, but at least like for the kind of problems that we can kind of foresee happening for like highly intelligent systems, we can try to like generate examples for current systems of like analogous problems, like with goal misgeneralization and so on, and then like we can learn kind of how these problems play out, and then like try to learn, for example, how to kind of detect these kind of problems in advance, and like what kind of mitigations we can like come up with for current systems. And like some of these things might not carry over, but I think it's like I don't see a reason to be like very confident that they won't carry over. So it just seems like kind of the thing that we'd want to do.
I think this relates to like one claim about optimism, whereas Yudkowsky is often seen as, so the writer of the original post is often seen as more pessimistic than other people. So he claims that we will get a bias towards optimism until we get some very strategic failure. And my impression so far is that you're maybe a bit more optimistic than Eliezer.
Well, I'm certainly more optimistic than Eliezer.
So would you consider yourself an optimist in the alignment space, or do you have optimism about the future?
Like, relative to most alignment researchers, I'm probably like a bit more optimistic than average. But I'm not exactly sure what the distribution is. But I think in that claim, I think Eliezer was talking particularly about like maybe the machine learning community, or like not necessarily like people working in alignment, but just like people who hear about this problem and have some kind of like cached thoughts about like how they would solve the problem. So I think he's talking about like how like when if society tries to deal with this problem as a whole, then they would have a bias towards optimism. Like in particular, like if people who are building AGI are thinking about how things could go wrong, then they have a bias towards like being able to fix things because they've always been able to fix problems in the past.
Right.
So I'm not sure he's talking specifically about alignment people. I think climate people have like thought about the risks and like how things don't work a lot more.
So I think what people are interested is kind of more precise evaluation or like how you approach the future. So this is not a very pleasant thing to think about, but what would you consider is the probability of Victoria Krakovna dying from AI before 2100?
I mean, 2100 is very far away, especially given like how quickly like
Yeah.
the technology is developing right now. So like, I mean, off the top of my head, I would say like 20% or something.
So that's pretty optimistic. It means like 80% of the time we have some very advanced AI and you're still alive.
Either that or like advanced AI doesn't happen for some reason,
Right.
or maybe we like cooperate on like slowing it down, or maybe we like uh, build AI that's like advanced enough to help us solve the alignment problem while it's like not advanced enough to like cause a lot of issues and bad outcomes. So yeah, I think that's just like, yeah, I mean, there's a lot of uncertainty about the future. I think it's like, yeah, it doesn't seem reasonable to me to be like, very confident in optimism before very confident in pessimism.
Mm-hmm. I still feel like 80%, like 20% is kind of confident in optimism. But
I would say like, a 20% probability of doom is still like, I mean, that's plenty enough reason to work on the problem. Right. Like it just like, yeah, I think there's a wide range of probabilities of like bad outcomes where like you would end up kind of acting in much the same way. It's like, the probability is high enough that you want to like, dedicate a bunch of time like doing the research and trying to, solve governance challenges and like ensure cooperation and so on. If anything, I think I've seen like people who are like really optimistic kind of start giving up. And like I think we've seen some of that happen with Miri. I think at some point they just kind of like seem to like not work on the problem so much anymore because they feel hopeless, and that this just seems like kind of counterproductive.
right. So it's instrumentally useful to be optimistic.
It's like, I mean, it's part of it is instrumentally useful, but also like I think like we just don't know enough to like to take this like extremely pessimistic stance that like it's almost impossible to avoid bad outcomes. Like there's just like so many ways that like the future could go that we have no idea about.
It should be like a distribution over Victoria's.
Yeah. I'm not really like confident in this number at all. It's just, yeah, I think like, yeah, I think it's most problematic if like some people think that it's like literally 0% probability or like something very low because like they're super confident that like technology can't go wrong, or that like maybe we will never build AGI, or that AGI doesn't make sense as a concept and therefore there's nothing to worry about. Like
Right.
yeah, I'm not sure. Like yeah, I think like yeah, a lot of these kind of like objections don't really make sense. But like yeah, I think we just can't be like that confident in either direction.
So this relates to how confident we are that the problems we're working on right now are kind of solving things in alignment, so are addressing the most lethal problems, as Eliezer says, or if we're kind of working on things that are kind of irrelevant for the future. Yeah, do you think we made progress on the more lethal problems, so the more important problems in alignment, or are we kind of working on less important things?
So I think this is another like argument on the list that like bakes in some assumptions, in particular about like what the most important problems are, or like which problems are kind of like deal breakers if they're not solved. And I think there's some disagreement on this between like Miri people and the rest of the community as well. So like this also connects to like the the sharp left turn threat model that we'll be talking about later in this conversation, where like this is like, I think this is like the main threat model that kind of Miri has put forward. And so like that's kind of their their claim about like what they think the most difficult problem is, like the most important problem is that like there's likely to be this like rapid phase transition capabilities and like the alignment techniques like as they think are kind of unlikely to hold up during that transition. And they think that like this is the main problem to solve, and if we don't solve it, there's just it's everything else is useless. And so I think that's kind of what they're pointing at. But like I think a lot of people in the alignment community might not agree that like that's we have to solve that problem, or that like this like sharp left turn idea is like necessarily that likely. And so like there might be like solving other problems like how to make sure that we can, you know, um, like how, for example, like how do we like solve an interpretability problem? Like how do we like uh, give ourselves the ability to like inspect, um, the system's like beliefs and goals and so on. And that's also like a hard problem, but maybe like a somewhat better defined hard problem. So like I think we are like making some progress on like scalable oversight and interpretability and other maybe like some foundational progress on like understanding agency and so on. But like I think like it's unclear whether we'll make enough progress on this before like we actually have to like apply these techniques.
So scalable oversight is we have higher and higher levels of oversight, so smarter and smarter agents capable of overseeing the other models that we're training. It could be AI or humans, I believe. And yeah, maybe define quickly the sharp left. I don't think you've defined what's a sharp left turn.
So I just said that it's it's the idea that like there might be like a rapid phase transition in the system's capabilities where like a lot of the like the capabilities of the system, like planning and modeling the world and so on, like become a lot better, and that like if there is such a phase transition, then like alignment techniques that worked before the transition don't necessarily kind of continue to work because like the system like starts like thinking about the world very differently and like might acquire like different objectives and just like um there are various reasons why that might not work. So like there's this analogy with thing that they make with kind of with human evolution, where some point we kind of rapidly increased our capabilities, like we invented like agriculture and writing and like um, got much better at like planning and pursuing our goals and like uh, acquired various concepts like scientific understanding of the world and so on. And so like now we are kind of less aligned with the kind of goals that evolution built in for us than we were before. So that's like that's a kind of like that's an analogy with humans that like is kind of being extrapolated here for AI systems. But I think there's various ways in which like AI is different from humans, and then like AI designers are different from evolution. So like there's a lot of like important disanalogies there as well. So that's like one of the problems with like thinking about the this idea of the sharp left turn, that like we don't really have examples, and so depending on like where your intuitions come from, you can come to very different conclusions about like how likely it is and how problematic it is and so on.
And you try to clarify all the assumptions made in the sharp left turn. So I think it's a good transition to move into your other post, which is refining sharp left turn. So there was a first post by Nate Soares. I think this is the one you're responding to. And we tried to define the sharp left turn. Maybe it's the first time someone defined the sharp left turn. And you wrote the post maybe like a few months after, trying to put all the claims together and try to define all the implicit assumptions. Yeah, do you want to? I don't know if it makes sense to summarize Netroy's post, or just maybe like give the main idea and then maybe give your idea why you wrote your post.
So like part of the reason that I wrote like a kind of distillation of this threat model, or like a summary of like how we understand it, is that like I think the original threat model seems a bit vague, or like it wasn't very clear like exactly what claims it's making. Like it sounds kind of concerning, but like we weren't sure how to interpret it. And then when we were like talking about it with like within the team, then like people seem to be kind of interpreting it differently. So it just seemed like it seemed useful to kind of arrive at a more like kind of precise like consensus view of what this threat model actually is, and like what implications does it have. Because like if we like if we decide that like the sharp left turn is like sufficiently likely that like we would want like our research to be more directed towards like overcoming dealing with the sharp left turn scenario, that like that implies maybe different things to focus on. So that's one thing that like that I was wondering about, like to what extent like do we agree that this is like one of the most important problems to solve, and like what the implications actually are. In particular, like I think we're not very clear at the beginning, like what exactly the claims are that are made by the threat model, and like what we ended up with after like discussing it among ourselves is like breaking it down into 3 claims, where like the first claim is that like, a like rapid phase transition will happen at some point, where like an AI system that like becoming increasingly general at some point, like will undergo some kind of like transition in capabilities, where like it becomes a lot more capable and like maybe like getting better at like a lot of different domains at once. Like maybe it just like acquires some kind of like better planning ability that has that would have like a lot of implications for different tasks, and then that would just kind of become like a qualitatively different kind of system. So that's like the first claim, is that like you get this like rapid phase transitioning capabilities, rather than like, for example, like very gradually improving capabilities in a way that like the system is kind of always similar to the previous version of itself. So that's the first claim. The second claim is that like, assuming that such a phase transition happens, like our alignment techniques will stop working. And the third claim is that like humans would not be able to like effectively intervene on this in this process. For example, like deciding like to, detecting when like a sharp left turn is about to happen, and like stopping like the training of this particular system, or maybe like coordinating to like develop some kind of safety standards, or just like noticing warning shots and like learning from them and so on. So that's like, so and these are all kind of like different ingredients for like a concerning scenario there. And something that we also like spend some time thinking about is like, what could a mechanism for sharp left turn actually look like kind of what would need to happen within a system like for that kind of scenario to unfold. Because that was also like, that was kind of missing from the original threat model. It was just kind of pointing to this analogy with human evolution, but that wasn't actually clear like how would this actually work for an actual like machine learning system maybe.
Right. So instead of thinking about it as like an agent or like a black box, you try to see how it would like be implemented in like standard deep learning techniques, and what it would mean for like generalization. So I think when you said about like the first claim is it's able to become very good at many domains at the same time. So that would mean that the thing is capable of generalizing to like many domains. So I think that's the first. That's the first claim. Second claim is where the alignment of our systems won't generalize as well as the capabilities. And the third one is that we will not be able to stop it. Is it basically right?
I think a second claim I would phrase more as just like, the alignment techniques kind of don't generalize while the capabilities generalize, because sometimes people also kind of make this comparative statement of like capabilities will generalize more than alignment does, but that like, I'm not sure that really kind of makes sense to me, because like we want alignment to generalize well enough to like still lead to like a system that like acts in a human compatible way. Like I don't think it has to like generalize as well as capabilities do, but I'm not, but also I'm not sure like what that means. Like maybe this seems like kind of comparing apples to oranges a bit. So I think the question is like, do the alignment methods generalize enough when capabilities become much higher?
So yeah, one thing about generalization is that like the kind of dangerous part is if the model is able to generalize well enough to disempower all humanity and like cause an an existential threat or lead to catastrophic outcomes. And so the question is, so if the model is able to generalize well enough, it will be able to like find those plans to take control, even if it's not being trained on it explicitly. But I guess one disagreement I had when reading your post was that like there are plenty of scenarios where people take over on the internet. So if we train foundational models on the internet, maybe the model will have this in its training data. So do you mostly agree that it will have the kind of plans to disempower humanity in the training data, or does it require generalization?
I don't think that like the internet has a lot of like particularly effective plans to like disempower humanity, and I think like I think it's not that easy to like come up with a plan that actually works. And I think like coming up with a plan that gets past the defenses of human society requires thinking differently from humans. So like I would expect there would need to be like generalization from like, the kind of things people come up with when they're like idly thinking about like how an AI might take over the world and like something that would actually work. Like maybe one analogy here is like how like, um, for example, like AlphaGo had to like generalize to in order to come up with move 37 that like no humans have thought of before, that like allowed it to like defeat a grandmaster and Go. Well, if it was just like following the same kind of strategies that like humans already know about, it probably wouldn't win the game. Like would be like much less likely to. So like I think AI would need to come up with like move 37 type ideas or to like actually like effectively like be able to gain control of of human society, like the infrastructure of our civilization and so on. Like maybe come up with like novel ways to like hack into data centers or whatever.
It's kind of sad to see the move 37 as like a way of disempowering humanity. Like,
Yeah, I think there's like, I would say there's an important point there where like the same capabilities that give us like really creative and interesting like solutions to problems that like move 37 could also produce like really undesirable creative solutions to problems that like we would have like AI rather than that we wouldn't want AI to solve. And I think that's one argument that like I think is also on the AGI ruin list that like I would largely agree with, that like it's hard to like turn off the ability to come up with like undesirable creative solutions without also turning off the ability to just like generally solve problems that we want the AI to solve. Like for example, like uh, if we want the AI to like be able to like, for example, cure cancer or like solve various like coordination problems among humans and so on, then like it would like a lot of the capabilities that would come with that could also like lead to bad outcomes if the system is not aligned. And yeah, sometimes like I like to make an analogy between move 37 and various like specification gaming examples, like the AI is like exploiting a bug in the game, or like generally like finding ways to like exploit the reward function. Like from the AI's perspective, like these things are the same, like the same like creativity and like general search process that like leads to move 37 leads to these bad solutions as well.
right, for it to just like another action on the board is not something surprising. It just for us humans, we don't like we don't see like going in circles in a boat race game to be like something very normal, but for the AI it's just like another action. And just about the move 37, as a human that was playing Go at the time, I was rooting for Lee Sedol, and so I was not happy. I thought the move was beautiful, but I was not happy when everyone said that the AI would win, because I was rooting for the human at the time. So for some people that not a DeepMind, it was a terrible move. um, so yeah, when to move on to the other claims about alignment, maybe not generalizing the way we wanted to generalize compared to capabilities. You mentioned in the post that we will need some qualitatively different kind of alignment techniques for it to work, or that is not just something that's about like quantity, but also about quality. Yeah, do you want to explain a little bit more what you meant?
So that's just a restatement of the claim that we think is made by the threat model, that like I think the claim was that like the kind of alignment techniques we have now are not going to work, so we just need to like come up with very different alignment techniques from like the current research agendas. And that's like, yeah, I don't necessarily agree with that, but yeah, that seemed to be part of what was claimed by the threat model.
So you don't think we need some very qualitatively different techniques?
I mean, it's plausible. I'm not sure whether it's necessary. I think, yeah, I think in principle it's plausible that, for example, like the the mechanistic interpretability agenda with like that focuses on like identifying like kind of what different components of a neural network are doing. I think it's possible that like if this goes far enough, then we'll have like a good enough understanding of the system and like what kind of at a higher level that would like you know, it would be useful for aligning systems or for detecting when they have undesirable objectives and so on. So I mean, it's also possible that it won't be sufficient. But yeah, I think I don't see fundamental problems with current research agendas. I think I mean I did read the the follow-up post by Nate where he was kind of trying to point out what he thought were reasons that those research agendas won't work. But I think it didn't cover all the research agendas that that the alignment community is pursuing, and also I think some of those objections were more on an intuitive level, where just saying that interpretability is really hard, we probably won't solve it, rather than very specific objections. So yeah, I don't see fundamental obstacles to current alignment techniques working. But yeah, I mean, it does seem there's a lot of hard problems to solve. So I think it's more likely that we will just run out of time rather than that the current paradigms definitely won't generalize.
So I think this is kind of related to how fast you think things will be, and how fast the takeoff will be. And I guess if you're kind of thinking about not having a lot of time, then all the agendas will not work in the time constraint. So and it's also related to the other things we said before about how many warning shots will we have, and if people will be able to cooperate. So I think everything is kind of related.
I mean, I think we should distinguish between how much time we have until there's right, advanced general systems have been developed versus how quickly they would develop. So yeah, difference between timelines and takeoff speed. Because yeah, I think I do have relatively short timelines, but I also I don't expect super fast takeoff. I think yeah, yeah, I'm more on the slow takeoff side of things. So yeah, so I mean, but yeah, I think that the short timelines could still lead to there not being enough time. But also,
what do you mean by short timelines?
I guess I mean just the amount of time until until AGI has been built.
I mean in terms of
just a number of years. I don't know.
In the median number.
10 or 15 years maybe. But yeah, as usual, very wide error bars here. It's also possible that scaling laws will stop for some reason, and then we might have a lot more time than we thought. Or yeah, various other factors.
So you see the current alignment agendas leading to good outcomes in this time frame, or making enough progress in those time frames to be confident that we have systems that are.
Yeah, I think it's possible. I think yeah, it depends on how many really good researchers we have working on these agendas. I think also whether we can get assistance from AI systems and in doing alignment research. There's some people who are working on kind of how to make language models kind of useful for alignment research, for example. And then yeah, I think it's quite plausible that there would be a few years where we have AI systems that are useful for alignment research, but before we have full AGI that can be that can be potentially quite dangerous. So yeah, I think in that window of time we could make a lot of progress on these research agendas as well, and iterate on systems that are kind of similar to AGI but not AGI as well. So
you mean transformative or
yeah, transformative AI systems. I think yeah, and yeah, there are lots of yeah, there might be various ways to buy time and have kind of increase that time period where we can potentially make a lot of progress in alignment with by getting some help from somewhat advanced but not quite AGI.
Isn't there a problem if we use AIs to align our AIs and we still haven't figured out how to align the first ones?
Yeah, I think that the alignment requirements for the systems that that you're using to help with alignment research, I think like would be less strict. Like, I mean, I'm just talking about like, you know, using like GPT-3 or GPT-4 to like, help like critique alignment ideas, or like, come up with like different ways of like thinking about the problems and so on. I think like that level we can still like verify whether like the system is being helpful.
And it's not advanced enough to produce like deceptive plans for an over long time horizons. So the last claim we haven't talked about is the third one, about whether we could prevent we wouldn't prevent the AI from having a deceptive, let's say, deceptive sharp left turn or like bad sharp left turn.
I mean, just like preventing a sharp left turn in general, right?
No. So yeah, I think like preventing bad outcomes, or like whether humans will be able to like align the transition. So I think this is roughly the third claim.
I guess we also I think we haven't like talked about some things about the second claim.
Go ahead.
Or like I don't know if you want to go into that first, but I guess like in the follow-up post that I recently wrote, I was looking at like kind of what is like what I would see as like our current like default plan for like dealing with a sharp left turn. And like my understanding of that is that like ideally we would want like as like to find a system that's like sufficiently aligned like before sharp left turn that it would like try to preserve its goals like during that capability transition, as opposed to like just trying to do the alignment during a sharp left turn, which just seems like a lot more difficult. And that's like I think that's the kind of like objection that like Nate's follow-up post was making to like various current alignment techniques like ELK, like eliciting latent knowledge, for example. But I like my general impression is that like the the default plan is not to like try to align a system during the sharp left turn, but like try to like align it enough beforehand that like you're more in the situation where the system is trying to keep itself aligned, and maybe like human designers are trying to like help it avoid various pitfalls. So then you're kind of working together with the AI system to like preserve its goals. And I think for this like the system doesn't have to like be like already an aligned superintelligence or something. Like I think we can have like a system that's like weakly goal directed, but like has the capacity to like reason about its own goals, and that can still be easier than like doing like long range planning to achieve those goals. So like I think one analogy here is once again is like what happened to humans when humans went through a sharp left turn.
Wait, humans went through a sharp left turn?
Well, this is like the whole analogy where like of course like for I mean the human sharp left turn kind of happened on the I mean it's fast on an evolutionary time scale, while of course for humans it felt very slow because we're kind of slowly accumulating like different skills and abilities through the cultural evolution. But the idea is that like if you take like let's say if you take a caveman who's like whose descendants are going to learn to do agriculture and writing and so on, then like I think that the values of the caveman kind of got passed down in like a relatively effective way. Like now that we've like acquired all these skills and concepts, like we still like value a lot of the same things, like human relationships and so on. So we just I think like if you take the caveman as an analogy to like kind of like a weakly goal directed system, so like someone who like doesn't make very long range plans but like has some preferences or like is trying to like get their environment into like certain configurations, at least like in particular situations that were like they know what to do, then like like that if that kind of entity acquires lots of capabilities, then like they will still try to like preserve what they valued before. So that's I think like at least based on like the human analogy, like we can expect that like a system might like try to like preserve its previous preferences. So that's kind of like that's the overall argument in my second post, where like focus on like kind of first like finding this kind of like weakly aligned system for a sharp left turn, and then like helping that system get to a sharp left turn, and then we don't have to worry about like trying to align like a system with bad goals during a sharp left turn. Ideally, we just don't want to go there at all.
So ideally, if the model is able to preserve its own goals, then we won't have to force the model to preserve it. It will do it for us, and we just have to insert the right goal at the beginning.
Yeah, or like find a system with like sufficiently like beneficial goal at the beginning. So like finding the system might be difficult, but like so that's where like we need a lot of like interpretability tools, and like we might need to like restart that search a bunch of times, like if we like detect like signs of deceptive alignment and so on. So like it might be quite hard to find that system, but but I think that like my impression of like current alignment techniques, what the current alignment techniques are trying to do is mostly like kind of find that kind of aligned system in the first place, and that's also something that Paul Cresciano was talking about in his comment on on that on that post was where like Nate was critiquing various like alignment approaches and how they kind of how they don't like address the sharp left turn enough. Like so that so Paul was kind of making this argument that if you have like your weakly aligned system, then like it would have the incentive to like preserve its own goals, and then like you're kind of on the same side as opposed to like being like in an adversarial relationship with the system. And then like he described like different like possible like mechanisms for the sharp left turn and how you might like help the system like keep itself aligned. So that's that does seem like just a more promising path than like trying to align a system during the sharp left turn. And like if you've done a good enough job with like finding an aligned system in the first place, then maybe like your interpretability tools don't have to like keep reliably working during a sharp left turn, because you can like expect that your system will generalize correctly. So even if like you don't have that insight into its goals anymore, then like you might still be fine.
So even if the AI becomes much smarter than it was before, and you don't have all the interpretability tools to see exactly what it's doing or thinking, if it's preserving its goal, you can just be assured that it's probably going to be beneficial if at the beginning it was beneficial. So I think in the comments by Paul Cresciano, or in other parts of the post you're mentioning, so your follow-up post, and then maybe one of the posts by Spencer, there's something about internal search, and like I guess there's like the goals that we can decide what these are. Maybe like let's say the outer goals, like the outer reward, those kind of things. And then if the model is having an internal goal is kind of different, and so there was something about it being like harder to change the goals that are like internal goals inside the system versus like the goals that outside the system. So maybe like the reward function we give it or something. And do you think about those kind of scenarios? Do you think there's going to be like different goals inside the system, or do you think roughly there's going to be like one goal we need to align?
Yeah, I think there could be like different goals inside the system. I guess I'm not sure what exactly the question is. I guess like it's possible that like there's the whole like goal misgeneralization idea, where like the system might like represent some other goal than what we trained it for, and then like we would need some way to like elicit that like through like different alignment techniques, like either like interpretability tools or like some kind of like possible solution to eliciting latent knowledge and so on. So like I guess like what you were talking about there is like one mechanism for a sharp left turn is that like the system could learn to run its own like internal search that's like faster than like the outer optimization loop, and then like could make itself like much better at planning or something, and maybe like it's something that like it would be hard to like align from the outside. But yeah, the idea with like the kind of the goal aligned model is that like if you build a model that also kind of can predict how like running this kind of internal search could change its preferences, then like it would also want to like avoid that happening. So then like yeah, it's just like we are kind of trying to be careful about uh you know aligning AI systems, which we could see as like humans running an internal search or something. Then like similarly like uh if the AI system is running some kind of internal search, then like we want to make sure that that has like beneficial outcomes according to its current goals. So then like yeah, I guess we would want to like that reasoning to be like explicit enough that we can like I guess communicate with the AI system about that. So then like yeah, ideally like uh, we would kind of find an AI system in the first place that like would want to preserve its goals in that way.
So yeah, to the extent that the AI understand that it is goal and wants to preserve them, whatever, if it is like internal search or like other types of goals, it will still like find a way to maximize the chance of its goal being preserved over time.
Right. Of course, that could still fail in some way, and then like maybe the system doesn't like foresee uh how it's how the internal search might like change its goals and like over some long time horizon or something, and then like yeah, we would still want to help with that. So like yeah, I mean there's various ways that like I think this idea could fail, but overall it's still like seems relatively promising.
Seems worth trying. One thing I found interesting was how you found examples of how we could get some sharp left turn. So the AI becoming smarter by extending its memory by, for instance, how humans write. So it could just like write in Google Docs or extend its memory outside, um, or yeah, you could like find better optimization or um, yeah. Do you have any other examples of how it could be smarter, or is it just like roughly like getting better memories, like the main way you think about it?
Yeah, I think getting better memory is like yeah a pretty central example, um, or like yeah um, coming up with a better planning algorithm and then like um, using that repeatedly to like come up with better planning algorithms or something. Um, I think there was like yeah, I think like yeah, designing better prompts for itself, for example.
Less thing
Like
by step by step.
yeah, and sometimes like yeah, that could be like um, that could happen like yeah in a dialogue with humans potentially, like if the AI kind of like outputs the like yeah, I mean well sometimes like humans might try to use the AI to come up with better prompts as well, but also like yeah, I think there are different ways for that to play out.
Yeah, and in that case, the AI would have even if we give it the same compute or the same amount of time in terms of wall clock, it will have more subjective time to come up with better plans if it's capable of um, yeah processing more information per flop or something, those kind of things.
Right, or if it comes up with like a more efficient search algorithm, then like can do a better search for the same amount of compute.
Yeah, I think one key, I guess, term in your post that we haven't talked much about is situational awareness. And is situational awareness basically being aware of your own goals?
So I think more broadly, like situational awareness is just like the AI system kind of knowing that it is an AI system, it's being trained like to perform certain tasks, that like that it's like you know um situated in a broader world with a lot of humans in it, and like just like generally like understanding its place in the world, and that would include also like kind of what its objectives are. um so like yeah, for example, like if it's aware that like it's in a training loop, then like it knows kind of what the objective is that it was trained for and how it might be different from like what it has internalized and so on. So like I guess it's like yes, it's a mix of like self-awareness and also like having some kind of model of the world and like its place in the world. So for example, like if you go back to the AlphaGo example, it does not have situational awareness because all it knows about is the Go board, and it doesn't know that like there's a whole world outside the Go board. While like we would expect that like when we do eventually build like general AI systems that they would like have situational awareness. I think like the kind of current large language models show some level of situational awareness, but it's not clear how much kind of like how reliable that understanding is versus like if it's just something that they've kind of learned to say that like I am an AI system, I've been trained to do X, Y, and Z. So yeah, I guess that's something we also like want to like get better at detecting in our AI systems as well, because it's like it's an important property both like for alignment and for misalignment, because like if the system like develops situational awareness when it has like beneficial goals, then like the situational awareness is helpful for like preserving those goals and so on, and then like acting cooperative way with humans. But if it acquires situational awareness when it has like goals, like undesirable goals, and like that, then the system is more likely to become deceptively aligned, because like then like if it has goals that are incompatible with our interests, and then it acquires this understanding like, oh, I'm being trained for such and such purpose, which actually is like not not what I really want. That like that's I guess kind of speaking as the AI system, like imagining being the AI system, then like then it would have an incentive to like hide its sexual motivations from the designers, or like play along with the training game. It's like that's a term that AGI was using in her thread model. That's like a good way to think about it. Like the system would like want to like play along with whatever tasks you set for it, so that we would continue training the system, and then like at some point deploy the system in a kind of in a setting where like maybe it would have less oversight. So
so we
so this
we
is
both
so
want
this is,
to
so what I'm saying is that like the situational awareness is like can be a prerequisite for deceptive alignment, and can also be a prerequisite for like the model becoming more aligned. So like really we want to like be able to tell when does the model acquire this ability, and does it acquire this ability under the right conditions.
so ideally we would want some kind of algorithm where we try to pick the best model, and we start by looking if it's, I don't know exactly where we start, but we try to avoid models that are like situationally aware, or that preserve their own goals and are like not aligned, and we try to avoid and we try to find models that preserve their own goals. And so in some way we start like, how do we start, how do we pick the model that we want that can like be both aligned and have its and preserve its own goal? Yeah, I think in your post you give like some kind of algorithm on like how to actually find the correct one.
Yeah, I think like as we search for a goal aligned model, there are like certain kind of criteria for like stopping and like restarting the search, because like if we found a model that like that is deceptively aligned, then or like shows some signs of kind of concerning behavior, we probably like don't want to continue training that model. Or if we find a model that like has situational awareness but like doesn't have any particular goals, like we probably like I think in that case we also probably want to restart the search, because you don't have like as much control about like which goals the system acquires first, and then like once it like becomes more goal directed and it already has situational awareness, like it might become deceptively aligned. So I guess like the kind of like the way I'm currently thinking about this, which like I'm not super confident in, but like my current view is that like you would want the system to first kind of gain some level of goal directedness towards like goals that are desirable for us, and then acquire situational awareness. So like we would want to like detect like in what order these things happen. And of course, like we would need some ability to tell when a model is goal directed and so on, like maybe some kind of tests or some kind of like interpretability techniques. So this being able to do this relies on kind of more advanced alignment techniques than we currently have, but I think that could come out of the current alignment research agendas.
Isn't there a risk of like, if we run into a model that is like deceptively aligned, and is also like situationally aware or like capable of preserving its own goals, that it could already be like the moment we like kind of test it and we run it, it's kind of already dangerous.
So I think partly this approach relies on like there being some kind of early warning signs of deceptive alignment, where you don't just go like from one step of SGD when the model is just not goal directed, or like just kind of not that competent, and then like next step it's already deceptively aligned model, and like doesn't seem as likely to happen. I think like I would expect like deception to develop more gradually, or like these are kind of
I feel like one step of SGD is kind of a straw man, because
a little bit, yeah.
we don't test our models every step of SGD.
Sure, but I mean, like, yeah, if you replace one step of SGD with like
We do
the
batch.
interval between testing,
like batch size is like 2000, or like I don't know. I don't know
but
how
still, like, I
big
mean,
the batch
usually
is.
these models are kind of fairly similar. Like, I also would expect that like the system would need to like experiment with like different weaker forms of deception before like it becomes really good at that. Like, of course, yeah, there's always like some like bad properties that you don't catch, but yeah, I would expect that like there are some early signs of the model being misaligned that you would be able to like you'd be able to pick up on. Yeah, because also like, I mean, if you're using like both like interpretability techniques and also like various behavioral tests on the model to like detect undesirable goals or situational awareness, like the model would need to kind of fool all of them at once. And yeah, I guess I wouldn't expect like, I think it's not that likely that like the model will be able to do that. I think like, yeah, I think this also depends on like not expecting like a super fast takeoff. Of course, if you have like if you have super fast takeoff, then like you could I think yeah, this would be more likely to happen. But yeah,
For people who are not familiar, takeoff is, by takeoff you mean going from general AI to like self-improving AI, or something that is able to disempower humanity? Like, what's the
I guess well, here, sorry, maybe I don't need to talk about takeoff here. I just mean like if you have a system that just like becomes much more capable very quickly. So like if you're like, if you're training the system and like it goes from like being like not particularly goal directed and pretty bad at deception to like boom over the next like you know a few batches later it's just like superhuman at deception or something, and I can avoid both your interpretability tools and your behavioral tests, and like yeah, I think that's like I mean, of course, the kind of phase transition would be like harder to deal with, but also like, I mean, there are other like alignment techniques, for example, like trying to like predict phase transitions and capabilities in advance. So like if you think it's like likely enough that like the model is about to undergo this kind of phase transition, you can also kind of stop training early and try to find like try to find some other way. But yeah, I think the more likely way for this to fail is that like the people working on AI capabilities will like run out of patience to like do all these tests and all these like restarting the search a lot and so on, and like or that like people wouldn't want quite this much overhead. So I think probably the amount of overhead is a bigger obstacle, but maybe we can like bring that down like as we keep working on this.
Yeah, I feel like if we ask people to run a bunch of alignment or safety benchmarks every batch or something, it's kind of too much of a requirement. So in your post you mentioned, I think, so in the follow-up post you mentioned 2 steps. So the first step is like finding the right model through search, if I understand correctly, and the second one is something about preserving goal alignment during the sharp left turn.
And in particular, like the second step is like where the model itself is like trying to preserve its goals, and like potentially with with some help from the human designers.
So how could this fail? I think you give some examples, I'm not sure.
So one way this could fail is that like it's hard for us to help the model because like we don't like maybe we don't have like good enough interpretability to like kind of to see how it's reasoning about its goals, or like what kind of like maybe it's hard to communicate with the model about like what consequences it predicts for like, undergoing a capability transition. It's also, I mean, on the model side, it might be like just kind of difficult for it to foresee some of the more subtle consequences of a capability transition. So even if like the model is like trying to predict what would happen, it might fail. So I guess also just like in terms of like trying to help the model go through this transition, like if the model ends up kind of with very different like concepts from us, then it might just be hard to communicate about like how its goals might change.
So we've kind of like talked about like outer reward function of like and like what kind of goals the model might have internally, which is kind of vague definitions, right? But I think you try to clarify everything in this like third post we're going to talk about now, which is paradigms of AI alignment. And for me, it was very clear, and it made a lot of sense. And I think it would be like helpful to the listeners to like have those kind of distinctions. So I think the first definitions we need is maybe outer alignment and inner alignment. I'm not sure if this is the way you start. Maybe you just like
I
give
think that's fine.
the overall idea of the post. Maybe paradigms of alignment.
This was my kind of like overview post for like what's going on in alignment research and like what are kind of the different parts of the problem that we need to solve. And in particular, I like to kind of distinguish between work on like alignment components and alignment enablers, where like components are like different kind of elements of an aligned system that we need to get right. In particular, say that outer alignment and inner alignment are like different components, and while like enablers are just like research like alignment techniques that make it easier to get the components right. For example, like interpretability or foundational work. So in terms of these components, like I think I find it helpful to think about like different levels of specification of the system, where like you have what's called the ideal specification and the design specification and the revealed specification. And the ideal specification is like what the designers have in mind when they build the system. So basically like the wishes of the designer. And the design specification is like what you actually like specify to the system to do, for example, the reward function. And then the revealed specification is like what you can reconstruct from the system's behavior, like what it seems to be like, what kind of goal it seems to be pursuing. So for example, if you like derive a reward function from looking at what the system is doing. And then if we look at the gaps between these different specifications, the gap between ideal and design specifications correspond to like outer alignment problems, where like there are some ways that we want the system to behave, or some like norms or constraints that we wanted to respect that like we failed to specify in our reward function or whatever. While like inner alignment problems are the other gap between design and revealed specifications, where like even if your design specification is correct, the system is still doing something wrong. So in particular, like goal misgeneralization is a way that like inner misalignment can happen, because even if you have like a correct objective function, then the system can still learn like a different goal that kind of coincides with the objective function on the training data. So the system just doesn't have enough information about the design specification to like learn the right goal. So this is kind of the way I would break these down.
So there's the designer specification, then there's the revealed specification, which is how the model behaves. Is there like a third one?
So there's the ideal specification, then design, then
right.
revealed. Yeah.
So ideal specification is what would we want ideally to satisfy human preferences?
Yeah. So maybe this is like, the true human utility function, if there's such a thing.
It seems like when you're saying this, you don't believe in such a thing.
Well, I mean, that's why we call it the ideal specification, is that like you can't actually write this down. Otherwise, you would just like, you would make that into your reward function. So that's something that like we don't, have full introspective access to.
But can
But
we
then like
approximate
so
it?
we can try to approximate it.
Do you think there's something like a coherent extrapolated evolution? Like if we could like decide what humans would want until the end of time, like what would humanity agree on if they had infinite time?
I mean, that might be a thing, but it's not very computable. I think it's like I'm not sure that's something we'd be able to figure out just by thinking, because we actually have to like experience different situations to find out like what our preferences are there.
You need to like simulate
So,
humans.
yeah, but this is like, I think there's a lot of like much more obvious ways that like design specifications like omit various parts of the ideal specification. Like, if you think about, for example, a side effects problem, that's an example where like, it's much easier to specify like what we want the system to do than what we don't want the system to do. And like, it's really hard to like specify like all the different ways we don't want the system to like change the world, which is like part of our ideal specification. And so like, if you have these like missing parts of the specification, and the system might just like interpret that as like us being indifferent to those variables when we actually aren't. So yeah, that's just one example of how like the design specification can be mismatched from the ideal specification, because it just has to be a lot simpler.
Maybe the ideal specification would be something like try to do whatever the humans do and be uncertain about humans' goals and like ask questions. And if we try to like specify all the different cases, like it's not an actual specification. It's more like in terms of outcomes than in terms of like a list of rules, right? It's like what kind of outcomes we would want.
Sure, you could say that.
And yeah, just to go back to the inner alignment, outer alignment things. So to make it clear for everyone, the outer alignment would be if we're aligned between the ideal specification and the design specification. So it's the designers or the AI engineers are writing the right thing, are able to like implement the ideal specification, kind of very close to the design. And the inner alignment is if the design specification is actually what the behavior we observe in the model. So like if the model behaves the same way as we programmed it.
Yeah, I guess like, I would say that inner alignment falls within the gap between the design and revealed specification, but there are other problems that are also in that gap. For example, robustness problems, where like the system might fail to behave according to design specification, not because it has like some kind of misaligned objectives, but just because like because of like various robustness failures, or like some other reasons, like maybe like adversarial inputs or whatever. So not everything in that gap is inner misalignment.
Right. So it's part of the things we're looking for. So I think I'm going to skip the elk thing. So you already defined multiple times goal misgeneralization. So you defined multiple times goal misgeneralization before. I'm going to do this again. You defined multiple times goal misgeneralization before, but in your post you try to like solve it or like try to mitigate it in multiple different ways. I don't know if you remember all the different ways in your post, but yeah, do you have any promising way of solving goal misgeneralization?
I think we don't really have a very good solution to it yet. I mean, there's various other, because there's various things you can do to like decrease the problem, like try to like have more diversity in the training data, so that you like include more situations that like disambiguate between like different possible goals the system could learn. But it's kind of difficult to predict like all the different kinds of data diversity you might need, or like all the ways in which like new situation might be different. And like we kind of in our paper we distinguished like between like ways to mitigate goal misgeneralization in general, and ways to mitigate like deceptive alignment kind of goal misgeneralization, where like the system like not only learns some undesirable goal, but kind of tries to hide this from us. And then like then we can try to like use interpretability tools to like detect what kind of objectives the system might have, or like whether like detect when it's being deceptive. Like for example, if like the system is like maintaining multiple models of the world, and like uh, you know, maybe one model of one of these would represent like what it actually thinks the world is like, and like how it actually models the world, and the other one is like how humans think about the world, and it's trying to like get us to like, you know, um, interpret its actions in a certain way and so on. I mean, this was sorry, this was not very clear, but yeah, like at least like yeah, we can maybe draw some parallels with like how like what deception looks like for humans internally, where like the human is like trying to convince others of something they're not true. They have to like, you know, keep multiple scenarios in their head, like what is actually going on and what they're trying to convince the other person of. So maybe we could, I mean, this is how it ends up. Like if it turns out that it works similarly for AI systems, we might try to detect that. But yeah, there are various other things like we can do. Like for example, we could apply methods like debate, where like um, you know, you have a kind of like self-play scenario between two AI systems where they try to point out flaws and like what the other AI system is doing, and maybe using interpretability tools on each other. And so like the kind of the opponent in the debate could try to like to help us discover if the other AI is like deceptively aligned. So there are various approaches. I think that they do rely on like better interpretability than what we have right now. But I think in principle this is possible.
When you mention interpretability, this is more of a alignment
Enabler,
enabler.
right?
It's
Yeah.
something that can enable us to solve those gaps in alignment and or help us think more clearly. So you mentioned mechanistic interpretability. Is there like any other enablers?
So the kind of things that I would consider enablers are like, work on mechanistic interpretability, like trying to build an understanding of like how the AI system works and like what the different like components are responsible for and like how it represents like different kinds of knowledge and so on. Then there's like, just like understanding different kinds of like bad incentives the systems might have, and like whether we can like detect those kind of incentives in particular systems. And there's also like foundational work, like generally trying to better understand like what is goal directedness and like how can we tell if the system is goal directed, and like what is it like to be like an embedded agent, like an agent that's not separate from its environment, and how do we think about like that system having goals and like things like that. So like if we make progress on like our understanding of this kind of phenomena, then like we can also like we're also in a better position to tell whether our components are actually working.
So you think embedded agency or like trying to figure out how model things when it's like embedded in the world will be kind of useful to align our models?
Yeah, I think like particularly like the the kind of considerations that come up in research and embedded agency that are about like the model being able to potentially like modify itself in some ways, like even in like you know limited ways. I think that could be like relevant to like uh, trying to think about what might go wrong, like even like a language model like designing its own prompts, because like a very limited form of self modification, you know where like insights from embedded agency might be helpful. Then like in an embedded agency scenario, like um people also think about like you know the model potentially having like sub agents that might have distinct objectives, and like how that works. And, like um I think that can also be relevant, like for example for language models that might simulate like different characters who like or kind of like sub agents, or who might you know like if they are simulated in enough detail, they might you know uh have some kind of a coherent motivations and so on.
Are you like pointing out at the like post um, about like simulators on the
Yeah,
phone?
that exactly that line of research. So I'm not sure whether like the kind of theoretical insights from the embedded agency agenda would like directly apply to this, but I think like just kind of like being aware of some of those phenomena, I think is helpful, like when thinking about like you know what can happen for those models as they like potentially like modify themselves and so on.
So just about the like simulation of other agents, do you think this would count as like having multiple agents inside of you if you were capable of like simulating a bunch of different agents?
I think there's like a continuum here, depending on like how detailed and persistent these like simulated agents are. But I think that could be the case. Yeah, I think like it could be possible for like a more advanced language model to like simulate like you know a very sort of like goal-directed sub-agent that would try to kind of like, gain control of the language model or try to get out or something. Like I'm not sure exactly what that would look like, but I think in principle that's a possibility. But also like I mean I think that's like outside the capacity of our current language model. So it would like might happen sometime in the future. Something might want to think about.
Does it make sense to talk about goals if they don't actually have like a actuators in the world or don't have a reward function? If it's just like a simulation by a language model, does it make sense to talk about agents?
I think it does make sense to like potentially think about those entities as goal directed. Like if the model is like prompted to simulate an agent, like if they're asked like what would such and such human do in this situation, or what would like a really competent person like do in this situation or whatever, then like it's trying to simulate something that is goal directed, and so like it's kind of running that kind of process somewhere internally, and then like that's like I think a lot of those considerations would apply. But I guess that the sub agent is not like it's not really separate from the broader model, so it's like so it doesn't have like I guess like the in terms of like taking actions, like it can like when the model is like simulating this agent, then this agent might be like talking to the human user who's like communicating with the model, but then like if the the language model then like goes into a different story, then like it's then this character is like not communicating with the user anymore, so it's kind of like not as persistent.
It's like an agent appearing in the world for one forward pass and then disappearing. It just like sends a message.
Yeah, it could be something like that. But I think it's worth thinking about like what does this kind of agency look like, and how does it differ from like standard like reinforcement learning agents that we're used to thinking about. Like whether we kind of how these agents could like act in undesirable ways. But so that's like, I mean, that's distinct from like the language model itself potentially like becoming more goal directed, like through fine tuning with human feedback or whatever. Then like it's still like it's able to act in the world by talking to humans, and maybe like, I mean, if you develop a model with like superhuman persuasion or manipulation ability, then like it would be able to like potentially get humans to do a lot of things, in which case like it is effectively acting in the world. So so that's something that like in some ways it's more safe because we do have like humans in the loop, but also like if it can like exploit human vulnerabilities to get them to like do different things, then like that's still concerning.
So we've kind of hinted at this goal directedness or what are goals for a long time. It's a bit late to ask the question because it's almost the end. But if you could define precisely goals, it would be something like you want the world to look in a specific way, and you tend to try to move the world in a specific way. So like the goal of breaking a vase is like going from this state of not broken to broken. What would like, how would you define goal direct, or just like goals more precisely?
Like you could say that goals are some particular states of the system, like states of the environment that like tend to be reached from like different starting configurations. So like I like the definition from the ground of optimization post on the alignment forum that was like defining like an optimizing system as a system that kind of like tends to end up in like some small set of like target configurations like from different initial conditions. And this doesn't mean that like from an arbitrary starting point you will end up with those target states, because like sometimes like the world is just too different and like you don't know how to pursue your goals anymore. But maybe if that from a wide enough variety of starting points, you end up with this goal, and like and this goal state, then you could say that like it's a goal directed system. So it's kind of a continuum. Like the bigger this kind of like basin of attraction is, so like the more different kinds of situations lead to these target states, the more goal directed the system is.
So it's kind of like going from a high entropy initial environment and like minimizing the entropy toward like a specific number of outcomes that are like, if most things end up with the vase being broken, then you can say that the thing wanted the vase to be broken.
I think you can put it that way. So like even if you like perturb the environment in different ways, that like the system would like find a way to like overcome those perturbations. I think that, yeah, there was a nice example on the ground of optimization post about like people building a house where like, you know, you have some configuration of like, you know, building materials and people, and you end up with a state that has a house in it. And then like if you introduce some perturbations, like, you know, you remove a wall or you know, steal some of their tools or whatever, then like, you know, eventually they would like, you know, replace them and then still build the house. But of course, there's some perturbations that are too large. Like, you know, if there's, you know, a giant earthquake and everyone has to evacuate, then maybe like, you know, they give up on building the house or something. So yeah, so there's always like some range of initial conditions. So yeah, I think it's a bit tricky to think about goal directedness in general, because like I think what we're really interested in is like whether the system has some kind of internal representation of like what are the target states that it's trying to achieve. But we can only observe goal directedness through behavior, at least not until we have like much better interpretability techniques. So like, and the behavioral definitions are a bit circular, because like we only like observe behavior on like situations that we have seen. And so it's hard to predict behavior in new situations without making some kind of inference about like how it's representing objectives. So yeah, there's a lot of like circular stuff going on here. It's like, it's a bit, it's been notoriously difficult to actually like define goal directedness in a useful way.
It's kind of similar to how we can like try to see the behavior of humans and try to like infer a reward function from it, like in inverse reinforcement learning, when you try to like look at how the like state and actions and rewards, and you try to like see what the human was trying to optimize. Wait, you only see the state and actions, and you try to like define a reward function from the behavior, but you don't you can only do that if you have the behavior in front of you. So I guess to end this, I would like to ask the questions asked on Twitter by Gary Marcus. So Gary Marcus actually read my tweets, and when I asked what questions to ask Victoria Krakovna, he asked, let me get this right. Has there been any significant progress in the misalignment of goals? So the mis is in parentheses, so it's alignment of goals. Since you started researching the topic, how serious a problem is it now?
Yeah, I would say there has been some progress. I think we have like a better grasp on what the problems are. Like I think we have a better understanding of like what some like outer misalignment problems look like and inner misalignment problems. Like, you know, we have like I think like when I started you know, working on this, we didn't have this like idea of like goal misgeneralization or, you know, examples of this like, you know, how this could happen. So like now we have like a better idea of like what is the problem we're trying to solve. So that's, yeah, I think that's one thing. Also, like I think there has been progress in, you know, interpretability methods. For example, like, you know, applying the kind of like circuits methodology to language models, which yeah, I think was yeah, I think it started out as like kind of technique like purely for vision models, and then of course like I think they had to like do it differently for language models, but like I think the basic idea of like you know, interpreting the network on the level of circuits seems to have transferred pretty well. So I think there's like, I think mechanistic interpretability is definitely like in a better place than it was like 5 years ago. So there's still like a lot of like difficult open problems, and generally like, you know, interpretability seems pretty hard, and yeah, kind of identifying like the goals of the system is still pretty hard. I think like we have like a somewhat better understanding of some of these things, and there's like a lot more people like with different angles on these problems that are working on them. But yeah, I would definitely say it's still a serious issue.
Any other last message for the alignment community or ML community as a whole, or anything you want to spread for our listeners?
I guess like I think for the ML community as a whole, like I would encourage people just to think about like the implications of like trying to get like really like capable systems to do what we want, and how that might be different from like from getting current systems to do what we want. Yeah, in particular, like we might not be able to like iterate as easily on powerful systems, or like detect when like you know, when there are like bad consequences of their behavior as we do with with current systems. And this is one of the things that makes alignment difficult, is that if we gradually deploy more advanced systems on different kinds of complicated tasks, and at some point we would no longer be able to foresee kind of the consequences of the model's plans, and that's why we need scalable oversight. And I think for really narrow systems, let's say once again AlphaGo, this is fine, because even if we don't really understand how the system's plan leads to winning at Go, then we can just we can be fine with it, because we know that it doesn't have any effects outside of the game. But if you're deployed advanced AI systems in more high stakes domains or in the real world, that it becomes more important for us to understand all the consequences of what the system is doing. And that's where we can try to use AI to help us understand what the AI is doing. But at a certain point, you can get into a kind of situation where where the let's say the AI is proposing some complicated plan on the level of some complicated mathematical theorem, and you try to and the humanists try to tell whether the theorem is true or false, but they might not have an expertise to evaluate all these consequences. So yeah, this is just one example of how alignment of advanced systems can be hard. And so yeah, I guess I would encourage people working on machine learning to kind of keep this in the back of your mind as as you're doing what you're doing, that there's the same ways that we can solve various bad behaviors for current systems might no longer work, and we actually need new approaches that for aligning more advanced systems.
Do you have any resource that people can look at, or website or papers you think are a good entry point?
So I keep a list of AI safety resources on my blog. So yeah, that's where I would usually point people.
What's the URL?
Krakovna at wordpress.com/AI safety resources. So I mean, yeah,
or just Google Victor Krakovna resources blog.
Yeah, I'm sure that people can Google that. So yeah, there's a lot of good overviews of the kind of the motivation for working on alignment, and why alignment is difficult, and what the current research agendas look like, and so on. So yeah, it's a lot of good stuff to read.
Cool. Yeah, on that note, thank you very much, and hopefully the world becomes aligned in 10-15 years.
Yeah, I mean, this is with wide error bars.